Many people make the assumption that climate change means that places will become warmer, and indeed, some will. But more important in some ways is how the climate in a particular geography might become more variable. Because if the temperatures, cloud cover and rainfall become less predictable and operate over a greater range than they have historically, this could affect how the ecosystems, the web of plant and animal life, in those areas can operate. And this week, scientists took the first steps towards studying whether this is a real risk and highlighting those areas we need to worry about. Alistair Seddon is at the University of Bergen, and he spoke to Chris Smith.
For this study, we use satellite data. Satellite data is brilliant because it provides a global picture with standardised methods of making measurements all across the world. And so what we did was use satellite data to create a new metric, the Vegetation Sensitivity Index, to measure the ecological response of ecosystems to climate variability.
When you say you sort of get response of the vegetation, how can you tell what plants are doing from space?
We can use satellites to measure how green that plot of land is. And so the greener something is, in general, the healthier something is. And the satellites can measure that from all the way up in space.
So you're going to say, right, we're going to look at areas where there are rapid or large departures across temperature ranges, rainfall and so on. And we're going to then ask which areas seem to be coping with that the best, they're the healthiest, and which areas are not. And then you can work out which might therefore be vulnerable or highest responding areas to potential changes in future.
Yeah, that's exactly it.
And when you do this, which areas emerge as particularly prone, do you think, to changes?
The areas that we found as coming up as being sensitive to changes is the boreal forest belt, or parts of the boreal forest belt, tropical rainforests, alpine regions, and then some dryland regions like the prairies and steppe regions in Central Asia and North and South America, and in the eastern areas of Australia.
And why do you think those particular areas are the ones that have emerged as showing a particular response to potential variations in climate? What's special about them? Why is that happening?
Well, this is the big question that we now need to address, because at the moment we have this observational study which has showed us how since the year 2000 these ecosystems have been responding. And the next key question to ask is, what are the underlying mechanisms? At the moment we don't know, but one potential thing to look at is historical changes in land use that might be influencing vegetation's ability to respond to climate variability.
Is that the next step then, to say, well, now we've got the observation, now we need to go and put some spades in the ground and see what's special about these areas?
Yeah, actually, I'm going to say not put spades in the ground, but put some corers in some lakes, because we're going to start trying to look at whether these trends that we see from the satellite era are persistent over longer periods of time by looking at the pollen that's preserved in lake sediments, which tells us about how vegetation has changed over thousands of years.
Right, and so does this also mean that scientists who are interested in how we may conserve or mitigate the effects of climate change will now also take your maps and say, these are our areas that might be at greatest risk, and so we also need to look at plant species that are there because they may be the ones that will be lost?
Yeah, totally. This is just kind of one component of a broader picture of how ecosystems can respond to different components of climate change.